Okay, this video is for day 10 of College Now PreCalculus with Mrs. Cucci. We are on file 1.1, Introduction to Graphing, so you should have that file open on your calculator. You will also need, along with that, a notebook because you are going to be doing some graphing by hand. If you have graphing paper available to you, that would be helpful as well. Next page. By the end of this lesson, there's a lot in this lesson. It will span 2 days. By the end of this lesson, you will be able to plot points. Hopefully you already know how to do that. Determine whether an ordered pair is a solution of an equation. Find the x and y intercepts of an equation of the form ax plus by equals c. Graph equations. Find the distance between 2 points in the plane and find the midpoint of a segment. Find an equation of a circle given a center and a radius, and given an equation of a circle in standard form, find the center and the radius. And you will be able to graph equations of circles. Next page. Okay, so many real-world situations can be modeled or described mathematically using equations in which 2 variables appear. We use a plane to graph a pair of numbers. To locate points on a plane, we use 2 perpendicular number lines called axes, which intersect at 0, 0, and we call that point the origin. The horizontal axis is called the x-axis, and the vertical is called the y-axis. The axes divide the plane into 4 regions called quadrants, denoted by the Roman numerals numbered counterclockwise from upper right around. So that would be 1, 2, 3, and 4. And again, this is review. You should know all of this. Next page. Each point xy on the plane is described by an ordered pair. The first number x indicates the point's horizontal location with respect to the y-axis. And the second number y indicates the point's vertical location with respect to the x-axis. We call x the first coordinate, x-coordinate, or abscissa. We call y the second coordinate, the y-coordinate, or the ordinate. Such representation is called the Cartesian coordinate system. We graph on a Cartesian coordinate plane. Okay, so we're going to graph and label the points -3, 5, 4, 3, 3, 4, so on and so forth. Okay, first point, -3, 5. So -3 is our x. We're going to go back 3. So 1, 2, 3, and up 5. 1, 2, 3, 4, 5. Here's our point. Okay, so back 3, up 5 gives us -3, 5. 4, 3. Forward 4, up 3, 4, 3. 3, 4, over 3, up 4. -4, -2. 1, 2, 3, 4, going back and then down 2. So there's your -4, 2. 3, -4, forward 3, down 4. Zero, 4, so over 0, up 4. -3, 0, back 3, up 0. And 0, 0, of course, is which we call the origin. It's right there at the center. Over 0, up 0. Okay, so that should have all been reviewed. No big deal there. You should all know how to plot points, and we're going to move on. Next page. Solutions of equations. Equations in 2 variables like 2x plus 3y equals 18 have solutions x and y. They're represented as an ordered pair such that the first coordinate is substituted in for x and the second coordinate is substituted in for y. The result would be a true equation. Okay, so we're going to see how these work in just a second. So determine whether, and excuse my spelling, whether the ordered pair is a solution of the equation. Okay, so in order to determine if the ordered pair is a solution, what we're going to do is we're going to use substitution. So x is -5 and y is 7, so we're going to plug that in. 2 times -5 plus 3 times 7 equals 18. So we want to make sure that this works. 2 times -5, of course, is -10, plus 3 times 7, which is 21. And we want to make sure that this equals 18. So is -10 plus 21 18? Well, no, it's not. It's 11. So 11 does not equal 18. So it's not a solution. Okay. Okay, so let's go to the next page. Determine whether the ordered pair is a solution. So same thing here, okay? 2 times 3 plus 3 times 4 equals 18. So we get 6 plus 12 equals 18. And indeed, 18 equals 18, so that is a solution. Okay, next page. Graphs of equations. I have all sorts of spelling errors. I apologize. The equation considered in the last example actually has infinite number of solutions. Since we can't list all of the solutions, we make a drawing. Call that drawing a graph, and that's how we represent them. To graph an equation is to make a drawing that represents the solutions of the equation. All right, so graphs of equations of the type ax plus by equals c are linear. Many such equations can be graphed using intercepts. The x-intercept of the graph is the point at which it crosses the x-axis, and the y-intercept is the point at which it crosses the y-axis. Easy way to find that, the x-intercept is always the point A0. You can find it very easily by plugging in 0 for y and solving for x. Same thing goes with the y-intercept. It's the point 0b, okay? X is always 0, so you're going to plug in 0 for x and solve for y. All right, so we're going to graph 2x plus 3y equals 18, and we're going to use paper. We're going to graph it on paper, and we're going to graph it by finding the intercepts. Okay? So you're going to need some graph paper out for this. Okay, so my equation was 2x plus 3y equals 18. And like I said, I want to use intercepts to graph this. You only need 2 points to graph a line. So let's find x-intercept first. We remember to find the x-intercept, we have to plug in 0 for y. And then solve for x. So there's your x-intercept. And similarly, we have to find the y-intercept by plugging in 0 for x and solving for y. Okay. So now my x-intercept is 9. So I count over 9 on the x-axis, right? And my y-intercept is 6. Okay. And from there, I connect with a nice straight line. Oops. And I should have one going each way. That's a terrible line. It's going to be close enough. Okay, so there's my line. And remember, you always want to label your line. And that was done simply by finding the x and y intercepts. All right, so make sure that you have that down in your notebooks. And let's move on to the next page. We're going to do the same thing. For this one, I'd like it on paper as well. And we're going to do this one by solving for y. Okay, so that slope-intercept form. So 3x minus 5y equals negative 10. We want to get y alone, so we need to isolate it. First step is to move that 3x. And then divide by negative 5. Okay, so your slope, 3/5, y-intercept, 2. When you're graphing from slope-intercept form, you always start at the y-intercept. Our y-intercept is 2. From there, we take our slope, rise over run. So you're going to rise 3 and run 5. So rise 3, run 5. Okay? And then connect. Okay, we're going to move ahead to the next page. So the last example, the value of y depends on the value chosen for x. So x is said to be the independent variable, and y is said to be the dependent variable. So again, x is independent, y is dependent. All right, so we're going to graph y equals x squared minus 9x minus 12. And we want to make sure that we include an appropriate graphing window or viewing region, meaning we want to make sure that our critical values are in there, our minimum or our turning point, okay? So we're going to come down here, and we're actually going to graph it in here. So Control G to bring up that function bar. X squared minus 9x minus 12. And go ahead and hit Enter. And if you notice that this viewing window doesn't look right, so we want to adjust it. And if you remember from last year, all we have to do to adjust it is double click on our window ranges and adjust them from here. So it looks like we're crossing through it a little bit less than -1, so maybe -3 would be an appropriate value for here. To get to the next one, we just hit Tab. How about 5? We don't need to see much more of this. Tab. Looks like we need to see way more of this. It looks like our other side of the parabola is on the other side of my 10. So how about we try 15? Tab. And it looks like we need to go quite a bit further down. Let's try -10 and Enter. All right, so did it work for me? No, it looks like I need to go lower on that y minimum. So I'm going to double click back down there at my y minimum, and I'm going to adjust it to -20. Well, that didn't work, so what do? We keep working, okay? -40. There we go. Okay, so now I can see the x-intercepts, I can see the y-intercept, and I can see my minimum value. That would be an appropriate viewing window. All right, next page. Okay, distance formula. Distance formula is something that you guys learned in geometry. Okay, distance formula finds the distance between any two points, and the distance formula is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. This is nothing new. You guys have used distance formula for a few years now. Okay. All right, so find the distance between -2, 2 and 3, -6. So again, here's your distance formula. I'm going to borrow it because It's easier that way. I'm just going to pop it in here. So here's our distance formula. Okay, so we want to actually plug into the distance formula. We're looking for D. Okay, and I'm going to keep D. I want to keep it going along with me. So square root. X sub 1 means my first x value, and x sub 2 means my second x value. Similarly, we have y sub 1 and y sub 2. Okay, so that's how you find those values. So we would have x sub 2, which we showed to be 3, minus x sub 1, which we showed to be a negative 2, squared, plus y sub 2, which is negative 6, minus y sub 1, which is 2, and squared. Okay. And then we're going to do out the math. We get the square root of 3 minus negative 2, which is 5 squared, plus negative 6 minus 2, which is a negative 8. Negative 8 squared is 64. And we have D equals 25 plus 64 is 80, square root of 89. Okay? And there we have it. That's finding the distance. Now I could find the decimal approximation for that if we wanted to. I don't mind radicals. I actually prefer that we leave it that way because it is the more exact solution. So we are going to leave it that way. Okay, so let's do it again. Distance formula. Okay, so here's my distance formula. We're going to go ahead and plug in. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. D equals the square root. Okay, negative 1 plus 1 gives us the 0 squared, which is 0, plus 2 minus negative 5, which is 7 squared, is 49. And the square root of 49 is 7. Okay, so what I'm going to do is I'm going to stop here, and we'll come back and start the next video with circles, because I do want to spend quite a bit of time on circles. So you guys are going to stop here. Your homework was to watch this video, and then you're going to do some practice in class tomorrow. So I will see you guys tomorrow in class. Thank you.